All right. Hi, everyone. Thank you so much for joining us. Welcome to our first ever Women in Elastic Security Summit. We're super excited to have you here. Today, we have two awesome ladies with us, Apoorva Joshi and Tanisha Turner. They both work in Elastic Security. Apoorva is currently a senior data scientist on the security protections team. She works on incorporating machine learning and statistical models into Elastic SIM product. And then Tanisha is currently a senior security QA engineer on the security analyst experience team. She does software QA testing for our security products. So just one quick housekeeping reminder, please be sure to post your questions at the chat. We will do a Q&A session at the end of the talk. And then without further delay, I'm going to go ahead and turn it over to Apoorva.
Thanks, Cami. I'm going to go ahead and share my screen in just a minute. Everyone can see my screen all right? All right. So hi, everyone. Really excited to be here today with Tanisha to kick off the Women in Security Summit here at Elastic. And today, Tanisha and I will be talking to you all about something called behavioral analytics and how it's useful when it comes to detecting complex security threats. And without further ado, let's jump right in. So today, I'll start off by introducing the term behavioral analytics and why it works for certain security use cases. I'll also touch up on the components of a behavioral analytics solution, specifically in the security domain. And I'll also try and bring all of this together using a real security use case, that is data exfiltration. I'll then hand it over to Tanisha to talk about how to convert these analytics into meaningful detections. So what is behavioral analytics? Behavioral analytics is a method for collecting and analyzing user interaction data to get a complete picture of how users are interacting with your product or website. And usually the goal here is to identify and fix gaps in user workflows and in turn to improve the user experience in your product. But how does this really extend to security? And more importantly, how can behavioral analytics help with detecting sophisticated threats, right? So the first thing to note here is that when it comes to behavioral analytics in security, we don't just have users, but we also have other entities in a corporate environment, such as servers, routers, and data repositories that we would want to look at. So when I say behavioral analytics here, we are actually talking about user and entity behavioral analytics, commonly known as UEBA in the security space. And the way UEBA can help detect advanced threats is by establishing baseline behavior for entities in a corporate environment and identifying when the entity behavior deviates from these established baselines. And this can prove useful for several security use cases. Take the example of insider threats, where it can be difficult to detect these threats if there's a zero-day attack when the attack pattern or the kill chain is unknown initially. But with UEBA, it can potentially detect these attacks even when it's a 0-day, because these attacks are almost guaranteed to make assets and entities behave differently from their established baselines. Coming to lateral movement, with UEBA, you can detect when a user moves laterally within an organization using credentials and machines that they don't typically access, or even data exfiltration, where a user tries to move data to an IP address that they usually don't interact with. And finally, something that you might not immediately imagine when it comes to UEBA, but it can also help with alert prioritization because it monitors entity activity across multiple data sources. So it has rich context, which it can use to surface the most important alerts for analysts to look at. Oops. So to sum it all up, there are three main components of a UEBA system. First, it looks at multiple data sources to get a full picture of what data is available for each entity. And the more data sources it analyzes, the more sophisticated attacks it's able to detect. The second component is something called entity risk scoring, and where the system maintains a risk score for each entity in the environment. And here, the more unusual behavior of an entity is, the higher the risk score. And this is kind of how UEBA escalates entities for further investigation. And finally, UEBA systems are able to provide context and explainability, such as the number and type of anomalous events detected for an entity, how the risk of an entity changes over time, all of which prove to be crucial when it comes to investigating a security incident. So to bring this all together, I'm going to take the example of data exfiltration and dig into how UEBA can help surface this activity in the Elastic security solution specifically. So we use the anomaly detection module available in the Elastic Stack to establish baselines and identify anomalous behavior. For data exfiltration specifically, and we are starting with exfiltration to repositories and to the cloud, we start by looking for suspicious volumes of traffic sent by a user to specific geolocations, or things like corporate connections from internal hosts to uncommon IP addresses. And the nice thing about the module is that each anomaly detected by it is associated with an anomaly score. And the intuition behind the anomaly score is the higher the anomaly score, the more anomalous the activity is. And this score can then be used to decide the severity of the alert generated based on this activity, which in turn can be rolled up into the risk score for the specific entity. So at a high level, this is kind of how our risk scoring capability looks like. It looks at alerts generated when anomalous activity is observed for a particular entity. And when I say entity here, I'm talking about hosts as well as users. So it starts with the base severity of scores generated, which are associated with the alerts, and then it applies some adjustments based on how recent the alert is and some entity-specific factors like, is the host a server? Is it a workstation? And then it generates an aggregated and normalized risk score in a 0 to 100 range for each entity. And it also assigns a risk level based on the score. Here's an example of what a risk score document looks like. So as you can see here, it has the entity name, in this case, a host, some metadata about what contributed to the risk, and finally, the risk score itself and the risk level. So this entity risk data as of today shows up in multiple places in the security app and can be leveraged to prioritize what alerts to look at first, or to decide what entities need immediate attention and action. And with that, I'm going to hand it over to Tanisha to talk about how these analytics can be used to hunt and detect threats. I'm going to stop share.
Thank you, Apoorva. Hi, everyone. I'm Tanisha Turner. I'm getting ready to talk to you about threat detections and how threat detections and behavior analytics coincides, and how we can use threat detections with the combination of behavior analytics for security research. So without further ado, let's get started. Okay, the first part, I'm going to explain to you what is threat detections, and then we'll get into threat modeling and the different types of threats that we have, and then we'll have threat detection use cases, and then I will tell you how we use these analytics to detect advanced threats for security research and analysis. We talk about what is threat detection. Threat detection is identification of malicious activity. It causes harms to network and access. Threat detection involves mitigation and investigation and preventive efforts to protect access from loss due to a compromised system. there are various different types of threats. That there's insider threats, and insider threats are anyone such as employees or any associates within an organization. You have social engineering as well. Social engineering tactics is one that is not easily detected exactly, but you have social engineering can be used by either spying or either logging or even calling someone and an impersonation. So that's one of the various techniques of social engineering. And of course, we have malware, malicious software. We have viruses, we have Trojans, and phishing. Then there's one that's very popular that we see now is ransomware. Oh, mouse did something. And to tie all these together, when we're doing threat detection, what is involved in it is threat modeling. When we think of threat modeling, this is evaluating all the cybersecurity threats, and it is used for threat identification. And when with threat modeling, it comes into the development of procedures. And threat modeling, we have various 5 steps and 8 methodologies. All this is used to determine how we assess risk and how we assess the threats, and how we are able to determine if these are indicators of compromise for the threats. The 5 steps of threat modeling is determine your security objectives, your risk assessment, asset identification, threat categorization, which is the threat categorization involves where you determine the risk of threat, or you determine the level of intensity of the threat. Okay, the severity of the threat, whether the threat is low, medium, or high, and that is based on your assets and the assets. And then from there, we have mitigation strategies. The 8 methodologies of threat modeling, which is, I'll briefly just touch base on these. We have STRIDE, Process for Attack Simulation and Threat Analyst, also called PASTA. That's a unique name that we have for. And CVSS, which is a Common Vulnerability Scoring System. That's the scoring system that we use to determine how these threats impact assets. And then we have VAST, which is a Visual, Agile, and Simple Threat. VAST, you can think of VAST as a way of brainstorming as well. Then we have TRIKE. TRIKE is one of the ones to where it's a framework, it's a threat framework that's used to tie all these together and to use for auditing purposes. We have attack trees. Attack trees are the levels of different threats threats and how they're used. And security cards is another brainstorming session. Then we have the hybrid threat modeling method, which is just combining different various threats and assessing them. You want to say, so how does this all tie into behavior analytics? Okay, first of all, when we have when we have an alert that's generated, when we have a detection rule that, say for instance, we have a detection rule in our Elastic product. Okay, we have one for where this particular one, in this particular example, this detection rule is identifying unusual process on a host. Okay, with this host, what we're seeing now is that this Linux host, say this Linux host is Almond Linux. This rule is categorized as a persistent tactic, meaning that there's various tactics that have been used to try to get access to the system. So this is one of the ones that this is called a persistent tactic, and it's determined by that Demeter attack framework model, which that's something that you can actually look at it. That's as well. That gives us a compass and a standardized way of where we can look at different threats and how they're evaluated and how they affect organizations. In this particular one, once this threat was detected, and it's saying, hey, this process does not look correct on Linux. I mean, what is going on here? What is going on here? This is something that is not normally on this particular host. So that's where this rule generated. And how we can use that with everything with behavior analytics, as Apoorva had pointed out before, where we have an anomaly, we can create an anomaly job for this, and tying that together, where we see these level of events. That's how we can use to piece these puzzles together in order to determine, with our investigation and analysis on and if this threat is an indicator of compromise, if it's an indicator of compromise, or if it's a false positive. Another example that I want to use is with this particular one, to where we're looking at a behavior analytics ML job that shows data bytes being transferred to a destination IP. Based on this data that we're seeing, this type of threat can be classified as data exfiltration, or data exfil for short. As you can see, this anomaly bucket score was very high, and when we're investigating these type of events, we take that type of score and then we investigate on the host. We take it, we filter the host and the timestamp, and we determine, hey, is this actually malware on this? I mean, we'll go and look at different other mechanisms on the host environment to tell if it's malware or if it's a potential indicator of compromise. This all could just be something that is this all could just be that it's just detecting something unusual, which is part of what behavior analytics is about, detecting unusual behavior on the environment. But once we take these metrics, once we take these, then this will be a piece of a puzzle that we can use to determine if the threat is actually on our assets, or if it's something that we can just classify as a false positive on the system. Another example that I want to show you of a rule that we have is of privilege escalation attempt. And this one this was a suspicious Java child process attempt on a containerized compute environment. And what this does, if you can, as you can see, what this had done, they were using wget requests and using process arguments to change the ownership. They were using the chmod command, which is a command to change ownership in Linux. They were using that as a attempt to gain access to the compute environment. But this rule that was created and generated had detected that, and it had blocked the traffic, and so that's what we're seeing here. When we look at these types of threats, and then in this particular case, I would look at this as an analyst, I would look at this threat. And then I would look at any other metrics that, if I have any anomaly detection jobs on, I would look at any other metrics associated with this threat to determine what's the next steps? How do I need to combat this threat? What do I need to do for improvement in order to where this will not affect our environment long term? In other words, this is the part where we have the mitigation strategies and the next steps that we will use. And we combine those with behavior analytics to determine our next steps in combating these threats. Okay, I want to ask, does anybody have any questions or anything? And for that, I will turn it over to Cami for any questions or comments.
Thank you, Tanisha and Apoorva. So there's no questions so far, but if you have any, please post them in the chat. You have just a few seconds here. Here's one. What are you most excited about moving forward with this work, from Jessica?
What am I most excited about with this? One of the things I'm most excited about with this is a way. This is a way to where this where you can tie using ML and using behavior analytics with and to identify and assess the threats. This is for me as a researcher. This puts everything combined together to where I can create a comprehensive report to determine, say, hey, I mean, hey, how does this work? I mean, if I just use not only am I assessing the environment, but I'm using other methods to determine how all this is coming together. So that's what I'm more excited about. And are we using behavioral data to train ML models? Yes, that's correct, Claudia. We are using behavior data to train ML models.
Yeah, we are mostly using the anomaly detection module because that's the easiest way to detect suspicious and anomalous behavior across behavioral data. So, but yeah, we are basically using ML models.
And the way, and to piggyback on that, and another thing too, that as a researcher, how this is going to be instrumental. Yes, I mean, you can create and generate alerts, but those are just not enough. When, as a researcher and as an analyst, you have to have a lot of different components in order to make an assessment on, hey, this is an actual threat, and what are my next steps? What are my next strategies on how to mitigate these threats? So this ties everything together. It's more of a comprehensive way of tying everything together. And with the behavior of these ML jobs and the anomaly detections, with the behavior of this, then you can actually determine, that's another piece of the puzzle that you can determine, hey, is this a high risk? Is this high risk or is this low risk? So with each threat, depending on the assets, and every organization is going to have different assets and different levels of risk, then you can classify that using behavior analytics to determine if these threats, the level of the threats, and how you can determine to resolve these threats for future. Is there any other questions?
I think Cammie's saying something, but you're on mute.
Just a goof with my links that I posted for the next 2 sessions. So let me go find corrected links really fast, if I can.
Does anyone have any questions about, as far as what's the best way to for threat assessment or anything like that?
You can just go ahead and tell us.
I can talk about this stuff all day. See, I can talk about malware and all this stuff all day. So but I don't want to overbore everybody with information overload, because that's why I'm cybersec diva. I just have to put that out there. That's why I'm cybersec diva. So, but yes, and one of the things that I did not show, and you'll see that in my malware sessions, introduction to malware analysis and reverse engineer sessions. You'll see a lot more in the sessions that I have up coming up. You'll see those in this month and in November, and I'll post those. What I want to point out, and I didn't dive deep in this, is that, say for instance, you created a anomaly detection job to detect malware, and we're using our Elastic product solution. Okay, and say for instance it was on your Windows host, and you're analyzing, and you see an anomaly event that's on there. A lot of times what will happen is some malware will hide itself, try to hide itself in the Linux, the Windows registry key files. So you will see that as well. So when it tries to hide itself within that, and say for instance with our solution, when it detects it, this is unusual, this file name in its registry file is unusual, and it doesn't match up. That's one of the things that our product can do. and then we create an anomaly detection job on that, and then it alerts us, hey, this is high risk. What is this doing? And when you go in to investigate that, and you could determine, hey, this is actually a malware on the environment, then that's something that you can actually use as a researcher. I mean, and once you dive in deep and research the events on what type of malware it is, and I won't go into all those details, high level details on what type of malware it is based on the registry keys, but once you use, you could use some behavior analytics for that. So that's one of the things I want to point out. I mean, that it came from the anomaly detection job that detected it, that it was something unusual. It was an anomaly on the environment that was going on the registry files on the Windows host, and then you're tying that in together with your malware research, and so that's how behavior analytics and threat detections go together.
All right, any other last questions before we wrap? Okay, well, thank you all so much for joining us today. And thank you, Tanisha and Apoorva, for your talk. We really appreciate your time. And just a reminder, I did post the links for the next 2 sessions. We are hosting a series this month for Cybersecurity Awareness Month. So next week, we will have Susan Chang, a principal data scientist here at Elastic. She'll be presenting on applied machine learning. And then the following week, we'll have a talk on the most diverse field of work, which is cybersecurity. So please register RSVP for those at those links that I provided in the chat. And again, thanks all for joining. Good to talk to you all. Any last words, Tanisha?
Bye, awesome people. Thank you for watching, and thank you for joining, and stay tuned for my malware and analysis and reverse engineering courses coming up soon. I hear you, everyone.
Thank you.